Omicron's webinars feature best practices and best-of-breed applications for the users of the OSIsoft PI System. Welcome to this new episode in our series. For more information, visit us at www.omicron.com.
Greetings, everybody. Welcome to today's webinar, sponsored by Omicron, a partner of EMI. Omicron's webinar series are designed to promote best practices for the OSIsoft PI System and best-of-breed layered applications like Data Validator that you will see today. I am Bernard, your moderator, and our presenters today are Oussama Himi, General Manager at EMI, and Joseph Haj Moussa, Technical Manager, also of EMI. We thank you for joining us and hope you find this webinar both informative and valuable. Today, we are addressing the best practice around the management of data quality in the process industries. Because we rely solely on sensors and manual entries, data defects are inherent to information management in the process industries. Left unattended, they will compromise the reliability and usability of data and impact negatively both operational and business goals. During this webinar, our speakers will present Data Validator, a solution designed for the OSIsoft PI System, which embodies industry best practices and clever tactics for streaming data validation. Our presenters are speaking to us today from Beirut in Lebanon and will introduce themselves shortly. Before I hand them the microphone, here are a few housekeeping rules. The presentation will last approximately 30 minutes, followed by 10 minutes of Q&A. If you have a question, submit it using the chat window on the right-hand side of the screen at any time during the presentation. We will answer all the questions at the end, and if we are left with some unanswered questions, we'll work on them and submit them to you by email after the event. The presentation will be available for you to download in the webinar room. We will also send you an email with a link to the recording in a few days. After the presentation, please give us your feedback so we can make this experience and subsequent webinars even more valuable. So without any further ado, I would like to invite our presenters to introduce themselves.
Good morning, everyone. Thanks for the introduction, Bernard. As Bernard mentioned, my name is Oussama Himi. I'm the operations manager here at OSIsoft Tech. I'm joined today by my colleague, Joseph Haj Moussa, who is the technical manager and the subject matter expert on the Data Validator application platform. I would like to thank you, everyone, for taking time of your busy schedule today to join us for this webinar. So starting today, so why are we here today? Just to give you a brief idea, we're today to discuss and talk about the data quality and the importance of the data validation in a real-time operation. Also, how to use the best practice in tracking data quality, leveraging both the existing OSIsoft PI system and the data flow hierarchy. So, data quality issue has been always a hot topic. One of the top challenges that we have heard from some of our clients today is the data quality issues and how much can they really rely on their data to make proper decisions. So we believe not having a way to validate the data could cause financial loss, time loss, and also some missing opportunities. So we look into data management technology. It's really important part, and it focuses on the depository of the data and the robustness of its historian. So how it's being historized. And the data quality and stagnation to help understand and manage the content of the data and its presentation to make a quick decision. Some corporations believe that their data are good enough. That would be very well right. However, they also may be missing some major opportunities to improve their efficiency by looking at their data. What we believe here at EMI that you need a tool to act beyond human interface capability to resolve the data issues in real time, and we call it TDV. So how does TDV excel in the data quality? Now, TDV captures and validates each and every value by the PI server against a set of provided quality check built-in rules. It also flags the value that does not pass the quality check. Very simple. So get data coming into the system, and then it gets through a different set of rules, and it flags what's not within the rule. So it also locates the data issue in real time. So where is exactly the problem? TDV pinpoint in real time your data flow issues from the central level all the way through your equipment, network, and historian. By using system-generated data quality check, we can look at to improve an overall equipment efficiency. By looking at the health check of the tag value and its location, user can pinpoint to the faulty equipment and can eventually improve the KPI. Looking at continuous improvement, beyond the human interface capability, when you have a lot of data coming in, TDV engine can improve the data quality and provide real-time KPIs, which can be used to drive both equipment and system improvement over time. I would like to take you quickly at some of the features. Let's look at some of the features of this application. Scalability. So the application is scalable enough and works based on MongoDB database technology. It classifies and flags that data for either a single node PI system up to PI server cluster or collective of number of PI servers. Capability of the Oracle and SQL. TDV ensures automatic integration database. For example, it works with AF and also works with Oracle on SQL databases. Easy of visual detection. So basically, user can easily visualize data issue, their types, their location, their classification, using a multitude of statistical charts that we'll show you in a little bit. Moving on, we'll look at some more features. This application is dynamic. The system allows dynamic number of levels while modeling your plant or your system. We can cover this part in a little bit more details. I'll show you what I mean by levels and how it's dynamic. AF mapping tool. So TDV has a mapping tool to create a data flow hierarchy. Certain companies might not have a data flow hierarchy. So this will help you generate your data flow hierarchy database, either if you have an existing AF. So that's from an existing AF data structure, then an automatic tool that maps both the AF into your TDV application. So, and the system is built in high speed response from the ground up. So also you can experience this in a little bit. Looking at next at some of the advanced features, we call them advanced features because of their flexibility, data transfer, and quality target of the data. So flexibility, basically, it requires a minimum of 3 levels of data flow. So this is what I mentioned earlier, the 3 levels: example, tag, interface, and PI system. Very simple, 3 levels. More levels could be plant tag, plant interface, plant PI, and then maybe PI to PI interface to the central PI system. And this is 5 levels. So this is what we define levels in the TDV. So TDV can work, as I mentioned, from one PI system or a collective of PI systems. It has the capability to write data back to the PI system. So if the user would like to see the data in the PI client tools, so you can have a history of the data analytics, the alarms that comes in with the TDV. And also it can integrate with a third-party system. So you need to export data from TDV. You can export to a third-party system to be used as well. The quality target, basically TDV allows the user to set the data quality target percentage. So user can compare data quality now versus the target. So how far are we from target? Are we good or not? There's also a preset of color conditions to represent the percentage of the data issue. That 0 to 25, the issue is okay. 26 to 50, you have quality issue, and so on, and the red zone. Now, some of the people might ask, okay, what is the mechanism? How does it work? What is the logic behind it? So I would like to take you on to show a couple of different scenarios and how is this mechanism works within the TDV. We're looking at the validation logic here. So assuming we have a 4-level, level 1 is a sensor level, level 2 is the equipment, level 3 is the DCS, and level 4 is the PI system. So the data flow will come from the sensor all the way up to the PI system through 4 different levels. Here we are assuming scenario number 1, data is good, no issues, life is good, I should say. Scenario number 2, basically if we have some of the sensors have data issues. So if we look at this here, we have 2 sensors not reading properly, and we have 1 sensor is good. So under the same equipment, we have 2 sensors with data issue. This implies that the issue at the sensor level and not at the equipment level. This is how we can first identify the location of the issue. Okay, so that's scenario number 2. Moving on to scenario number 3, if all the sensors under an equipment have data issues. So what does that imply? That if all the sensors on the equipment don't have data issue, that implies that the issue is at the equipment level and not at the sensor level. So hence all sensors are cleared and the equipment has the issue. Scenario number 3, we said all the sensors under the equipment are having issue, therefore it is an equipment issue, it's not a sensor issue. So all the sensors are cleared. So moving on to scenario number 4. So talking about the mechanism, if all the equipment under the DCS or the SCADA have data issues, as we see here, if both equipment under the DCS1 level are having data issue, that implies that the issue is not at the equipment level, it is at the DCS level. So this is how we track where is the location under each scenario. So if we look at scenario number 5, if all the DCS or the SCADA have connected to the PI server have data issues, meaning we're not getting data from the DCS, that means is the PI server. This implies that the issue at the PI level, and hence the DCS are cleared, and the PI server has the issue, not the interface, since we have good data under the interface. So this is just to show the mechanism that basically the PI system will be flagged, all the DCS are cleared, and the PI server has the issue. So I would like to take you quickly over an overview of the application, and you will be able to see that in live in a little bit. So the TDV overview, if we look here now that you talked about the application, and we can take a quick overview of how it looks like and what are the main components of the application before we start the live demo. We have the landing page here, where the users can select the time and look at the time and go back and check the data quality issue. We have an overall status to the right of the system and look at the number of the tags, the value, good value, quality issues, etc. We have 4 main subpages to the left tree, and also they are accessible from the main page. So one of the level monitoring chart and the node status chart, the data reliability KPI chart, and the tag reliability heat map. Moving on to the next page, the level monitoring chart. Quickly, basically what we are seeing here is that shows a representation of the data issue across different levels of the data flow. So basically tag, interface, PI plant, central PI system across the location. So each one of these on the bottom and the x-axis are the locations of the data coming from which side. So, and also you can look, and these are clickable, and the circles are clickable, and when you hover over them, it gives you an overall status, so you can drill down to the problem. Next, I would like to show you the node status chart, and this is a drill down status chart from the central PI system all the way to the plant or the interface or the tag. By simply clicking on the central PI system, you get into a list of the plants that are integrated or interfaced with the central PI system. And with one click, again, you can move on to what's under the plant. You look at the interfaces. You have one green and one yellow. And then you can click on the yellow with the quality issue. And then you move on to the number of tags. As we can see here, like 4 tags under the under this interface. So we have passed 4 levels already to get to the tag with 4 clicks. So this is how you navigate through the node status chart. Moving on to the data reliability chart, this page provides statistical evaluation on the number of the nature of the issues with capabilities of exporting these results as well. So it shows the percentage of each category. Basically, when you click on this, it shows you the percentage distribution of the quality issue, the good values are not applicable here, and these are clickable. You can export to Excel. This page basically very helpful to get an idea about where is the issues, what is the percentage. Moving on, you get the tag reliability heat map. Provides an immediate visual summary of all information across the entire tags versus time. So all the tags that has been in the issue across the entire timestamp, you can click on the tag and you get 1 hour before and after of the issue. So that's just an overview about the application in case hopefully the live demo will work fine. And then move on, I would like to share with you a nice catch that we call it catch of the day, or a catch that we have done with one of the customers. I want to share with you an event that happened at one of our customers and within an hour of installing the TDV application. At one of major electric and water utilities in the region here, they have 21 plants, about 23 PI systems. We integrated 10,000s of PI points were added into the TDV. Right after TDV was installed, a large number of data quality indications appeared at one of the sites. So the customer was surprised what's going on. We thought that something wrong, but within seconds we found out that a large number of tags have a data quality that falls under the quality check rules of TDV. The customer had no idea that some of the tags really outside the range, or if they are reading proper data point from the site. So we end up looking at the data that coming from the plant is really above range or below range of the identified profile of the data. So actually these were good indications. So at TDV were able to identify the issue within the seconds, and users were able to pinpoint to the issue with no time and within 5 clicks. Some screenshots of the application at that time. I have the name of the customer and some of the information highlighted for just privacy. You can see here we were able to quickly look at the tag that has an issue. By using the node chart status, we were able to look at the tags that have issues under that node and at the interface right there, and then drill down a little bit more into the data reliability. We were able to list all the tag name, the location of the tag, and the element, the quality, and we were able to export that quickly, and the location of the error. So also you can see the percentage of above range. We have a high percentage of the data above range, and this is what on one of the load dispatch centers. So they really need the data to be accurate. So they were reporting a lot of data above range from that site. So with that, I would like to take you into the TDV demo quickly. So it's coming up right now, the live demo of the system. It's some information here for only for demoing purposes. So as you can see, this is the live demo, the landing page. We have the timestamp here. You can click on the time, select the time that you want. And you can see here the overall good value quality check. These are clickable. You can select the location. You have multiple locations based on your site. If you have one site, you'll have one location. If you have monitoring a fleet of locations, you'll see that. You have also 4 levels here, the level monitoring, the node chart, data reliability, and the heat map. So looking at the level monitoring chart quickly, I would like to show you here the distribution of the data issues from the level up to different their locations. So basically, if I take an example of these here, LA, we have an interface issue. Also on the AK, we have a list of tags that they have issues. So I can click on, with one click, I can see all the tags correspond to that. You can see we have 2 in good, we have 5 quality issues, and we have 0 with no availability. So there's data coming, however, we have data quality issue. If the data is not coming, you will be having an availability issue. So this is with one look, you can see the entire fleet, and also you can click on the hourly slide bar here, and you can move with time quickly at 1 hour interval. And the right here, we can see the quick summary for plant, different level, or on an interface, or on the tag level, on a quick summary or tag versus location. Moving on to the node status chart. So this is the one I talked about as a drill down mechanism. So assuming that we have a quality issue at the central PI system, we have a number of tags. We have 33 tags as shown here. In one click, you get the list of the plants. We have 6 plants, 2 are good for having yellow quality issue. The data is coming, however, it has a quality issue. First plant has 9 number of tags, 9 tags in issue. The one that runs to the right has 7. So I'm gonna click on the first one. I can see you have 3 different interfaces. So each one shows a list of the number of tags. So if I click on one, I get 4 tags in issue. 3 are bad quality tags, and 1 getting good quality. So this is within 4 clicks, you can really see what is the tag that's causing an issue, or is it an interface? Moving on to the data reliability KPI chart. This chart shows you an overall KPI of the count of the issues. So here I have 22 issues, and also I have 1 which is 3% is not available. So if I look at the quality issue by clicking on this, I will be able to see the below range. I have 27% below range, 31% frozen, and 40% above range. I click on the on any of I click on any of the percentages. I can go more in details about the interface. I have 3 interfaces frozen, and I have 4 tags that they're not collecting data. I click on an interface, and it takes me directly to the location, the name of the tag, the interface name, and the path. What is the quality is frozen, and I can see the tag name. I can able to export this to Excel in one click, also for reporting purposes. The last but not least is the tag reliability heat map. So basically here it's showing me my entire fleet tags that they have issues. So we're looking at the tag. So if I go back for 1 day, I can see I have about 55 tags, and they were in and out of issues and over time. So if I click on one of the tags, I can see 1 hour interval before and after the issue happened. So it can show me quality issue, bad, and then eventually it was cleared. So this also all corresponds against time. So this is what I wanted to cover for the live demo for you guys today, and I would go back to the presentation, and we'll go over the TDV system architecture and what does it take to put TDV in, and I will give the floor to my colleague here, our technical manager, Joe Haj Musa.
Thank you, Usama. I would like to take you through the system architecture of TDV application. This slide will show us the TDV system architecture and how the workflow works, starting from the PI data archive to the client machines through the TDV web portal. Two services will be running in the backend continuously. The first one is for the quality check, and the second one is for the quality analysis. The quality check service is responsible for data reliability algorithm, which is the core of the TDV system. This service will import the data flow from whatever configured in the AF hierarchy created on the AF server and reads the data from the PI server. This service subscribes to the PI system, perform different type of real-time calculation and analysis on each and every value coming from PI in order to check the quality of these PI tag values. There will be two levels of analysis performed by the quality check service, as discussed earlier. One on the sensor or tag level and the other one on the parent level. Different type of analysis is performed by the quality check service on the tag level: frozen issues, noisy issues, below range, above range, and more. The service will also apply a roll-up analysis on the parent level in order to identify the quality of this level and check where the issue is coming from. The result of the quality check algorithm will be written to the MongoDB through the web API. Also, it's very important here to mention that this service supports multi-threading that allows to analyze big number of PI data at the same time. On the other hand, there will be another service running called Quality Analysis Service. This service is responsible for analyzing the data generated by the quality check service. It reads the AF hierarchy and generates the data for the chart based on the quality of the elements. The analysis is generated in a format that is read by the web portal and populated in the TDV charts. Please note here that the service is also capable to backfill the data in case of any service failure and can be scheduled to run in threads at a specific interval, which make it faster to generate the analysis for all TDV charts. All the communications with MongoDB are done through the web API. The next slide shows us the TDV prerequisites and sample implementation. Under the prerequisites section, we have the minimum versus recommended requirements. Starting with the PI server, the minimum requirements is 2012 version. And what we recommend is to have 2018 version or higher. Same, it will be applied for the AF server version. Also, having minimum requirements for IIS 7.0, 8 GB RAM, 2.0 as processor, and 5 GB available space. But also, we recommend here having IIS 10.0, 16 GB RAM, 3.0 processor, and 10 GB available space or higher than that. Finally, we should have minimum .NET Framework 4.7.2 version installed on the TDV web portal. Under the on-site services, part, we list a sample implementation where our engineers will work on the implementation services for the AF configuration, database integration, and TDV web portal configuration. The duration for this kind of implementation will take between 1 to 3 man weeks based on the AF complexity. Under the standard TDV delivery part, we will cover the AF synchronization and the TDV visualizations for the level monitoring chart, node chart, heat map, and data reliability. Our engineers will evaluate the infrastructure of the TDV installation. They will provide the requirements and recommended setup for the application. Of course, host a conference calls and or site visits that is required with the identified team to prepare a good environment for the TDV installation. TDV is COVID-19 proof application. It can be installed, configured, and deployed remotely. Deploying the solution, testing, commissioning, and performing training sessions can also be done remotely. Okay, this ends our presentation today. We just want to give you a quick peek about our customers. Our customer varies from oil and gas, petrochemical, power, water, and nuclear.
Joseph, Sama, thank you very much for this great presentation.
Thank you.
For everyone for sticking with us through the little technical problems we had today, which are unusual. We do have some questions. So the first one, what determines bad quality?
Okay, bad quality, we have a preset of rules. Bad quality, we have quality issues, so that's the yellow color basically that comes in the TDV. And we look at the percentage of the somewhere between 50 to 70% it calls bad quality. We have the preset of rules that we have is in frozen or the below range or above range. These are all within the bad quality category.
Next question is, what statistical methods are applied to determine what is good or what is bad? This is
yes, this goes back to the mechanism of the validation logic that we covered throughout the presentation. The statistical method that's applied here is based on the disconnectivity of the data between the levels. So we basically make sure we are in connect with each level, and if we are getting data through that level, we look at all the tags at that level. The statistical analysis is to basically looking at if all or else method, that if we're getting one data versus not. So with this, we determine if it's a tag issue or it's an entire level issue. That is in a nutshell. Of course, there's a lot more math behind it, but just to make it easier on the user to understand that we look at the level by level to determine where is the issue on the statistical part.
Next question, can you find sensor drifting?
A sensor drifting, I would assume that we're talking about drifting from normal operated value. We don't alarm on the sensor drifting. We can catch frozen data. We can above range, below range. Now, if we call sensor drifting that is drifting above the range or below the range, yes, we can catch it if the range is identified. But it's not in a predictive environment. We're not in a predictive analytics environment.
Does TDV require its own server to run?
No, it doesn't require its own server to run. It can be installed on a web server, existing web server.
Yes, all what we need is to install .NET Framework, IIS, should be as a web server.
Is that web API, is the Pi Web API or an Omicron developed API? That's
It's our own EMI developed API.
The next is, what configuration process do you use to associate interface with Pi tags?
Basically, the service will subscribe to the Pi system and will do our analysis on the Pi tag level for the data only. Okay, so whatever configured in the Pi system, we are subscribing the service to read the data values, and we're doing our quality check and analysis on that level.
Good. Thank you, everyone. Well, thank you for sticking with us again, although we had some little bit of difficulty during this webinar. I want to thank also Usama and Joseph for preparing this presentation and introducing this topic to all of us. Anyone interested to continue this discussion, you can contact any one of us here on this webinar today, and we'll be happy to discuss further details with you, including pricing and licensing for this solution. So we thank you all. You will shortly receive a message with the recording of this webinar. And as you exit, please give us your feedback, and you will be able to download the presentation that you saw. Thank you very much for attending.
Thank you for listening to this webinar replay. For more information, visit us at www.omicron.com or contact us at omicron@omicron.com. Don't forget to subscribe to this channel if you like the content.